We're excited to be at the forefront of the transformation to battery electric vehicles. With the most impressive portfolio of high-performance thermoplastics, fluoropolymers, and composites in the world, we are well positioned to address some of the most challenging trends in industry drivers for battery electric vehicles. Some of those trends include the move from 400-volt to 800-volt battery and e-motor systems, the shift from 400-volt IGBT to silicon carbide power electronics, as well as DC fast charging. My name is Brian Baleno, and I'm the head of automotive marketing. Throughout our history, we've been at the cutting edge of bringing innovation to downsizing engine technology. With our portfolio of specialty materials, we enable such technologies as turbocharging, gasoline direct injection, as well as exhaust gas recirculation. All of these technologies really enabled cleaner, more efficient, and lower carbon emission engines. Today, we are working on a portfolio of new innovations and solutions for the electrified powertrain. The electrified powertrain consists of the battery, the electric motor, and the inverter. Our materials are very well suited to improve battery safety as well as thermal performance and efficiency, to improve the efficiency of both the electric motor and the inverter, as well as to enable DC fast charging. Let's start with battery systems. Here, two of the biggest challenges design engineers face are improving the power density of the battery as well as addressing thermal runaway. With our SolF PVDF product, we can tackle the inside of the battery cell and improve the power density. SolF PVDF is used in both the cathode as well as the separator. Additionally, when we look at the portfolio we have to serve outside of the battery cell, we've developed some brand new products, including our Amidel PPA and Zyder LCP, that were specifically designed to address thermal runaway. These materials are well suited for battery insulation plates, which is the case of the Zyder product, as well as Amidel PPA, which was designed for battery bus bars. Other applications within the battery where we have brand new innovations include our Riton PPS. We've designed a brand new grade for battery coolant lines, and both Amidel PPA and Riton PPS are well suited for applications or components like bus bars, pyro fuses, and vent systems. One of the other areas we're working to address is the weight problem. We can both significantly reduce the weight of the battery as well as provide increased power density through space savings. In addition, we can also address the thermal runaway challenge with both our long glass fiber as well as our continuous glass fiber and carbon fiber materials. We recently expanded our expertise and significantly improved our capabilities in electric motor design by building a team that previously designed electric motors for automotive OEMs and Tier 1s. One of the areas we're really working to improve in electric motors is the electrical insulation. Here we can significantly improve the e-motor efficiency with our Agidium PEEK slot liner materials. These materials are very well suited to replace incumbent solutions like paper and paper laminates. And the main advantage of our Agidium slot liners is that you can also improve copper slot fill. Because you can make these slot liners thinner and they have better thermal conductivity than the typical paper insulation and the paper laminates, you can gain significant efficiency gains, as well as the potential to both lightweight and downsize the electric motor. In addition to our Agidium PEEK slot liners, we have a world-leading magnet wire solution with our Key-to-Spire PEEK. Here, Key-to-Spire PEEK is very well suited for 800-volt electric motors, where there's a need for increased thermal stability up to 240C. The other main benefit of Key-to-Spire PEEK over enameling is that Key-to-Spire PEEK is extruded. Extrusion allows you to increase both the reliability as well as the sustainability. Because the material is extruded versus enameled, you significantly improve the energy savings or reduce the amount of energy consumed during the process, as well as the potential to eliminate volatile organic compounds. Two other applications we're pursuing in the e-motor space are bus bars and high voltage connections. Here, both Amidel PPA as well as Riton PPS are very well suited for these applications. We recently introduced a brand new Amidel grade, Amidel Supreme, that offers a best-in-class comparative tracking index at 150C, as well as very strong dielectric strength at elevated temperatures. Additionally, our Riton PPS very well complements the Amidel PPA as both a bus bar material or a material for high voltage connections. Another recent trend for e-motor designers is to consider the use of a carbon fiber composite rotor sleeve. Here, the benefits of composites in rotor sleeves are twofold. First, you can spin the electric motor much faster. The second benefit is you can reduce eddy currents. Ultimately, what you can achieve is a potential cost savings by both reducing the size of the motor as well as reducing or eliminating some of the costly magnets. Let's shift to inverters now. Some consider the inverter to be the heart of the electric vehicle. The heart because it takes energy from the battery and moves that energy to the electric motor. Here, we were well positioned to address both 400 volt technology as well as 800 volt technology. Our materials are very well suited for insulated gate bipolar inverters as well as the next generation silicon carbide MOSFETs. One of the most sensitive applications within the inverter is the bus bar. Here, there are very challenging requirements. Some of those challenges include thermal shock performance, so taking the material from -40°C to 180°C over a range of cycles. The materials also need to be flame resistant, have a V0 flame rating, and also retain good dielectric performance at very high temperatures. In the case of silicon carbide MOSFET inverters, these temperatures can reach temperatures up to 175°C. Our Amidel PPA and Riton PPS have best-in-class grades that can address many of these requirements. Another important application in the silicon carbide inverters are the power modules. With increased thermal requirements as well as sensitivity to moisture, we've developed several new Amidel grades, Amidel Supreme and Amidel BIOS. Both materials have very high TGs as well as very low moisture uptake. In addition, we've developed V0 rated grades for power modules to address the safety aspect of the inverter. Along with Amidel, we have our Riton PPS, which also can be used in power module applications. Finally, let's talk about our brand new innovation with EMI shielding. This product has the potential to save up to 30% weight, as well as for design engineers to integrate functionality, as well as consolidate components. And that's how we enable cleaner, safer, and more energy efficient mobility.